This is the Pearson's Edexcel GCSE Mathematics Paper 2 Calculator Higher Tier Paper for the summer June 2017 exam. So let's start with question 1. So it says the table below has the probabilities that a biased dice will land on 2, on 3, on 4, on 5, and on 6. And we're meant to work out the probability or the missing probability. So name our rolls a biased dice 200 times, work out an estimate for the total number of times the dice will land on 1 or 3. So first we need to figure out what 1 is. So we know that the entire probability is going to equal to 1. So we have to add this up. So P1 plus P2 plus P3 plus P4 plus P5 plus P6. So choose a different color. So it's 0.1 plus 0.15 plus 0.09, 0.18 plus 0.17. All of this, okay, subtracted by 1 will give you P1. So our answer will be 0.31 if you use a calculator. And so we want now, so if we roll 200 times, okay, so 200 times roll. So we want P1 or P3. So the or represents sum. So that's 0.31 plus 0.18, which gives 0.49. 200 times 0.49 gives you 98. So this means that you can estimate that if you roll the biased dice 200 times, you will land on 1 or 3 98 times. That's the estimate. Question 2. So it says, on Saturday, some adults and some children were in a theatre. The ratio of the number of adults to the number of children was 5 to 2. Each person has a seat in the circle or had a seat in the stalls. 3 out of 4 of the children had seats in the stalls. 117 children had seats in the circle. There's exactly 2,600 seats in the theatre. So just a couple of things to highlight. So basically the idea is that we just want to, so on this Saturday, where there were the people on more than 60% of the seats, so that's essentially the exam question, how you must show how you get to your answer. So it basically wants to know, were 60% of the seats, more than 60% of the seats occupied on the Saturday. So the ratio of adults to the number of children is 5 to 2. So we know that there's going to be 5/7 adults, and we know there's going to be 2 out of 7 children. It's the ratio. And we know that if 3 out of 4 of the children had seats in the stalls, then 1 out of 4, so a quarter of children, had seats in the circle. Okay, so first of all, we say 2/7 times 1/4 gives us 1/14, and this is equivalent to the children in stalls. Okay, and this tells us it's 117. in the circle. So 117 equals 1 over 14, because it says it here, 17. So basically 117 times 14 is a total number of people. So that's 1,638 total people. And we know that so we know that 1,638 divided by 2,600 times by 100 is 63%. So 63% of seats taken. So obviously 63 is greater than 60. So the answer is yes, on Saturday, more than 60% of the seats were taken. So let's just run through that once more. So 3/4 of children had seats in the stalls. That means 1/4 of children had seats in the circle, because either stalls or circle. And we know there's 2 over 7 parts as a fraction of children, because 5:2 ratio. So 1/4 multiplied by 2 over 7 gives us 114 children in the circle. And we know that there are 117 children had seats in the circle. So 117 is equal to 101 over 14. So 117 times 14 will give us 1,638, which is 100% of the, so this is 100% of the people that were there on the seats. And 1,638 over 2,600 multiplied by 100 gives 63. Although it doesn't really look like a 63. There we go. Percent of the seats taken. Question 3. So the diagram shows a prism with a cross section in the shape of the trapezium. On the centimeter grid below, draw the front elevation, the side elevation of the prism. Use a scale of 2 centimeters to 1 meter. So because I don't have a ruler, please excuse my lines. So let's do the front. So we know that this is 2 and this is 2, 0.5. So it says 1 meter is 2 centimeters, 2 centimeters is 1 meter, and each one of these is equivalent to 1 centimeter. So that's 1, that's 2, so that's 1 meter, then 1.5, then 2 meters, and then same thing here, 1, 2, 3, 4. I have 0.5 here, so that means it's going to be 1 centimeter, and then we draw the line. Brilliant. So of course, when you're drawing this, it needs to be a lot more straight using a ruler, but just for the sake of this, I hope you understand. So drawing the side now. So this is 0.5. So again, half. So there we go. That's the side. Okay, again, make sure you draw your straight lines. Okay, question 4. So again, a lot of information here. Ollie drove 46 kilometers from Liverpool to Manchester. He then drove 61 kilometers from Manchester to Sheffield. Ollie's average speed from Liverpool to Manchester was 70 kilometers per hour. Ollie took 75 minutes to drive from Manchester to Sheffield. Work out Ollie's average speed for his total drive from Liverpool to Sheffield. So we just use our triangle. So we've got distance is given by speed multiplied by time, using our triangle. So he went from Liverpool to Manchester, and the time it took him was, it says, so 56 kilometers was the distance, and he was driving at 70 kilometers per hour, which is simplified to 4 over 5, and this is equivalent to 48 minutes. Okay, because 4 over 5 times 60 is 48. Right, and then so from Manchester to Sheffield, change color. So Manchester to Sheffield. So it says it took him 75 minutes. So the total distance was 56 kilometers plus 61 kilometers, tells us there. So 117 kilometers. And the total time, well, we know it was 48 plus 75 over 60, so 2.05 hours. So now the average speed is going to be 117 over 2.05 will give us 57.1. So again, let's go through this. We know that we use our triangle. So distance, speed, time. His journey is broken down into two: Liverpool to Manchester, then Manchester to Sheffield. So we want to figure out kilometers over the hours. So we figure out the kilometers first for the total journey, and then the hours for the total journey. So we know that he traveled from Liverpool to Manchester, took 56 kilometers, and he done this over 70 kilometers per hour. So 4 over 5. So in terms of the time, it's 48 minutes, because 4 over 5 times 60 is 48. And then for Manchester to Sheffield, it took him 75 minutes. And then that means the total distance was 56 plus 61, which gives 117 kilometers. And the total time was 48, which we got from here, plus 75, which we got from there, which gives us 2.05 hours because we divide by 60, and this is in minutes. And then the average speed is going to be the distance over the time, so distance over the time, which will give us the speed, and that is 117 over 2.05, which gives us 57.1 kilometers per hour. It says Janie drove from Barnsley to York. This is her average speed from Barnsley to Leeds, her average speed from Leeds to York. Janie says the average speed from Barnsley to York can be found by working out the mean between 60 and 80. If Janie is correct, what does this tell you about the two parts of the journey? Well, it will tell us that the time must be the same, because if she can even out the two speeds, and she says that her average speed from Barnsley to York can be found by working out the mean of 60 and 80, and that means the time must be the same. Question 5. So work out the length of AE. So we have AE here. We know EC. So this whole thing here is 8.1. DC, excuse the badly drawn lines, is 5.4, and then dB 2.6, and they're all in centimeters. Work out AE. So you can see that these two lines are parallel. So we can say 8.1 divided by 5.4 gives you 1.5. That means there's a scale factor of 1.5. So 2.6. So that's the scale factor. 2.6 multiplied by 1.5, 3.9. So we've got 3.9 centimeters. So AC is 6.15. So AC (6.15 centimeters), and it says work out the length AB. So it wants you to work out this length. Oh, no, sorry, not that length. It wants you to work out this length here, AB. So essentially all we need to do is again scale factors. 6.15 divided by 1.5, which gives us 4.1. So we have 4.1 here, which is BC, 4.1, and then we subtract that from 6.15. 6.15, take away 4.1, which gives us 2.05. Question 6. So Anil wants to invest 25,000 for 3 years in a bank, and he wants to determine which bank will give him the most interest at the end of the 3 years. So personal bank or secure bank. These are the kind of the deals. 2% for each year, and this one is 4.3% for the first year and 0.9% for the next extra years. So we know that our sort of initial saving is 25,000, and if we go for personal bank, that's going to be 25,000 times by 1.02, because it gives us 2% for each year, to the power of 3, because it's going to be for to the end of 3 years. So if we use a calculator, we get 26,530 and 20 pence. And if we use secure bank, so 25,000, and now we multiply by 1.043 because we get 4.3% for the first year, and then we multiply by 1.009 because you have 0.9% for the extra years, but it's 2 years, so we square it, which using our calculator gives us 26,546.46. So the best one will be secure bank because we get a little bit more, just over £16 more with secure bank.